In our previous session, we had discussed about the controllers and type of controllers. Now let us start off with the quadcopter example. The PID stands for Proportional Integral and Derivative Controller. The main aim of this example is to roll the drone to the left to reach the position A. So now we have a drone at position C and we are giving a proportional signal to move to the left. So proportional is the only signal that we will be giving to the drone. And let us assume that the integral and the derivative does not exist. Once we give a stick command to the quad to roll towards the left, the drone position will tilt towards the left. Therefore, for the first cycle, the quadcopter will start to move from position C to left roll and continue in that position beyond position A. The proportional signal to correct its position makes the quadcopter to roll to the right again. Once the position crosses beyond A, the proportional signal will again, in the cycle, will roll back to correct its position by applying a right roll. By applying a right roll, it will roll so much that it will overshoot and again it has to correct its position by moving towards the left. Hence, what will happen is it will oscillate right to left. It will oscillate due to large force being placed in the proportional that will not be flyable. Another problem with the proportional control is that when the quadcopter is tilted towards the left, that is when it's rolling towards the left, it reaches position B, which is not enough, but it has to reach position A. But the proportional signal will know that if it changes its position from B, it will overshoot and again it has to roll towards the right. Because it cannot go further than position B, the proportional signal will stop the quadcopter at position B, which comes to the next controller, that is the integral controller. So what integral does is, now that due to proportional signal the quadcopter is stopped at B, it analyzes whether the quadcopter has to be tilted more towards the left or how much of percent it has to tilt so that it can reach position A. It provides a plot of previous signal into the flight controller and decides whether the before movement should be continued or how much it should change to get to position A. So the proportional will get into threshold and not apply large correction to get to A. Hence the integral will correct the quadcopter from position B to get us to position D. It applies continuous movement at smaller amplitude to push the quadcopter to position A. But using only the integral without proportional will make the quadcopter very slow and disobey the commands and eventually crash the quadcopter, which gets us to another controller type, that is derivative controller. So here, after the slow correction of the input till input, the derivative will further put in some amount of correction to hit position A or to reach position A. It determines the most optimal cycle to reach position A in a particular time. At position D, the integral is working to give a push to reach position A, but the proportional is not working. Hence, the derivative and integral control play together to give a slight correction and predict when to reach position A. Hence, roll obtained by the quadcopter to reach position A. Derivative alone cannot do it. Hence, it takes help of the proportional and integral command. So, the quadcopter from position C will go to position A with the help of three controllers, that is proportional, integral and derivative control. From this PID controller graph, we can see that only by using proportional controller that there's an overshoot and a settling time. By using proportional and integral, the settling time is fast, but there's an overshoot taking place. By using proportional and derivative, there is a light overshoot, but there's offset also. But while using PID controller, there is a short time overshoot and the settling time is also fast. Hence, we get a faster response and our result is obtained very fast by using proportional plus integral plus derivative controller. I hope you would have understood today's session. Thank you.